This honors geometry lesson is on section 5.3 on similar polygons. The objectives for today are to solve problems that do involve similar polygons. Pictured below are two scale drawings of the same plot of land, one smaller drawing and one larger drawing. What do you notice about the side lengths and the angle measures of both figures? Let's start with the side lengths. So if you look at the corresponding sides, what you're going to notice is that they have the same ratio of 1 to 2. So if you take 50 to 100, which is this side right here, and you reduce your ratio, you're going to get a ratio of 1 to 2. If you take another corresponding side, so let's say you take 200 to 400, that also gives you the same ratio of 1 to 2. So the first thing we notice is that the side lengths are in proportion. The second thing I want to look at are the angles. If you were to take the smaller drawing and line it up to the corresponding angles of the larger drawing, what you're going to notice is that the angles are congruent for all corresponding angles. So the second thing we know about similar polygons is that corresponding angles are congruent. So when you think about similar polygons, I want you to think about blowing up a balloon. So when you blow up a balloon, the size is going to change, but the shape is going to stay the same. So when a smaller figure can be blown up until it's congruent to the larger figure, these two figures are said to be similar. A one-to-one correspondence can be set up between the vertices of figures that are similar. So here we have two pentagons. We have pentagon ABCD and pentagon VWXYZ. So let's start by naming the corresponding angles, which are going to be congruent. So we know that angle A is going to correspond to angle V. We know that angle B is going to correspond to angle W. Angle C is going to correspond to angle X. Angle D is going to correspond to angle Y. And angle E is going to correspond to angle Z. For our corresponding sides, we know that side AB is going to correspond to VW. And notice that I use what we call a squiggly or a tilde. That indicates that they are similar and proportional, but not necessarily congruent. The second corresponding sides that we're going to look at are BC is going to be similar to WX. CD is going to be similar to XY. DE, so DE, is going to be similar to YZ. And lastly, EA is going to be similar to ZV. So for our correspondence statement, we can now say that pentagon ABCDE is similar to pentagon VWXYZ. Please remember too that when you're using similarity, you're actually going to use that squiggly or tilde for the congruence or corresponding statements instead of using the congruent symbol. You should, however, make sure that when you're talking about corresponding angles that you do use the congruent symbol since those angles are congruent, and when you talk about corresponding sides that you're using the similar or the tilde, which indicates that they are proportional but not necessarily congruent. A scale factor is the constant ratio of corresponding sides of any figure. So here we have two triangles, ABCD and triangle XYZ. What is the scale factor of triangle ABCD to triangle XYZ? So we're going to notice that BC is going to be similar to side YZ. BC has a side length of 8. YZ has a side length of 12. So if we reduce our ratio, we can say the scale factor of triangle ABCD to triangle XYZ is 2 to 3. We can use the scale factor to find missing sides in corresponding figures. So if we want to find side AB, so we know that side AB is going to be similar to side XY. So what I know is that my scale factor is 2 to 3. And since I don't know the length of AB, we're going to call that x. So when we match this up, we know 2 is going to correspond to triangle ABC, and 3 is going to correspond to the larger triangle of XYZ. So since AB is in the smaller triangle, I'm going to put the x up here. And since 3 corresponds to the larger triangle, and AB is similar to XY, we can put 27 down here. Now if we solve our proportion, 3x equals 54, we can now see that the side length of AB, which we called x, is 18. So AB has a length of 18. So remember, if you want to check this, if you go ahead and substitute in 18 for AB, so we know that AB has a side length of 18, and that that XY has a length of 27. Remember, if we reduce our ratio, it should give us back the original scale factor. So 18 to 27 does reduce to 2 to 3. We can also use correspondence statements to fill in missing congruency or similarity statements. So we are given that quadrilateral ABCD is similar to quadrilateral PQRS. So using what we know about correspondence statements, we can now say that angle A is congruent to angle P, angle B is congruent to angle Q, angle C is congruent to angle R, and lastly, that angle D is congruent to angle S. We can also fill in some ratios and proportions using our congruency statements as well. So we know that AB is similar to side PQ, BC is similar to side QR, PQ is similar to side AB, and lastly, side RQ is similar to side CB. So if PQ equals 2 and AB equals 5, then the scale factor is, well, if you look up here, PQ is similar to AB, also using what we know down here. So if PQ is 2 and AB is 5, then the scale factor is 2 to 5. Here we are given that triangle ABC is similar to triangle DBE, and the scale factor from triangle ABC to triangle DBE is 5 to 3. The first thing I want to do is to go ahead and write what angles are congruent in ABC to what angles in DBE, and also what sides are similar. So we know that angle A is going to be congruent to angle D. Angle B in both triangles are going to be congruent to each other, and angle C is going to be congruent to angle E. We also know that side AB is similar to side DB, side BC is similar to side BE, and that side AC is similar to side DE. And we're going to use this information to complete the following statements. So let's start with our angle measures. So we want to find the measure of angle D. So going back to our congruency statements, we know that angle D is congruent to angle A. So angle A is 75 degrees, so angle D must be 75 degrees as well. Angle E corresponds to angle C, and according to our diagram, angle C is 40 degrees, so that means the measure of angle E is 40 degrees as well. Let's start with AB. So using our correspondence statement, we know that AB is going to be similar to DB. We know that DB is 9. So if we start setting up a proportion, let's say that AB is X, which corresponds to DB, which is 9. And if we set that equal to our scale factor of 5/3, we can go ahead and solve our proportion. 3x equals 45. So AB is going to be 15. Now we can go ahead and use the same process to find BC as well as CA. So if we look at BC, so BC is going to be similar to BE, and BE has a length of 15, so we can say x over 15 equals our scale factor of 5 over 3. And again, using what we know about proportions, 3x is going to equal 75. Therefore, BC equals 25. And lastly, if we look at CA, we know that CA is similar to ED. And if we look at ED, we can see that ED is 12. So x over 12 equals the scale factor of 5 over 3. So 3x is going to equal 60. And therefore, CA equals 20. So this is the end of the lesson. If you have any questions, watch the lesson for a second time. And after watching the lesson for a second time, if you still have questions, write down any clarification questions that you may have and bring them to the next class.